Hi, welcome to another edition of Java Programming. My name is Nate Nestler, this is for High Practice Studios. Okay, so we're going to create another project. We're going to call it File, Project. We're going to say Java Application. Say Next on that. And then in here, we're going to say Very Basic Arrays. Very Basic Arrays. Like that. And then we're going to say Finish. Now for me, I've already created this, so I'm just going to say Cancel for me, but for you guys, you say Finish. Alright. And then we get our package, very basic arrays, and then we're going to come down here and we're going to say public space class space very basic arrays, which already should be there. And then we're going to create something new though. And this is the static int create array function inside of our class. And then I'm just going to call this function back over here, and we'll go over our for loop too. So let's just cover a couple of things along with our ints. So this function, as we saw functions in the last video, is like a way of creating a container for your code where you can then just call it real easily elsewhere in your program. So like down here in our main, when I want to use this, I just simply call it right here and I just pass it a value. Now last time we didn't work with passing values, we kept it simple. But in this one we're actually going to worry about passing in values and returning them. So we're going to have to return a int array, and we'll go into an array in just a second what it is. This needs to be static because the main is static, so therefore this has to be static also. And then we're going to allow for an integer to be passed in. So that's what goes between these parentheses, things that we want to pass into our function. And in this case, we're going to pass in a variable called num_elements. This is be the number of elements, or how many different elements we want in our array. That'll make more sense in just a second. But basically, this is an integer. This is referred to as a parameter in programming. This is what this is called. And the values to pass into this function are called arguments. So this would be an argument here. Now, that's why they literally call this args right here. But so basically, a parameter is nothing but a special variable for a function that is one of the variables where values can be passed into it, or shall we say arguments instead of values. That's another way of saying it. And you might be going, why did they come up with this extra language? Well, it's so that when you're talking with another programmer, that you can tell a difference between a variable created, say, down here in the function versus the ones up here in the parentheses where values can be passed into the function. So it makes life a lot easier to understand what's what. Also, I'd like to point out that variables that are inside of a function are local to that function. They only have within the scope of that function, as another way of calling it, or you could also refer to it as granularity. Basically what we're saying, there's a bunch of technical terms, but basically what we're saying is that this variable only exists within this function when this function is called. This variable does not exist out with the rest of the program. Like before, we used properties in our class in order to handle values inside of our function and pass values in and out of it. But in this case, we're creating the variables only in this function right now, and they only exist within the function. So once the function is done running, it's destroyed and it no longer exists. There's something to point out though. When working in Java, when passing values into a function, you're passing by value when it's an integer, a float, a boolean, string. I think a string does too. It might be passed by reference. I don't know. String, I think though, is no, it's a string class. So no, it's not going to be. Okay, so yeah, integer, float, double, char would be the case. Boolean. These data types are passed by value. What we mean to say is that it copies this 5 into a place in memory, and then copies that into the memory location of num_elements parameter here. And that's passing by value. Passing by reference is where it points to the memory address of said variable or value, and that becomes the new memory location for the parameter. So the parameter shifts memory locations to the new memory location and points to it, and they become one and the same thing. So if you make a change in this variable, you make a change in another variable where it's passing in the value, becomes one and the same thing, and you won't know the difference. So that's what happens here for our returns. When we're returning this, it is an int array, and int arrays are passed by reference and not passed by value, which means we point to the memory address of this array. So my array's memory address is going to exist in RAM, and when we say my new array is going to get that new memory location. Now, I'll break that down a little bit more when we step through it and walk through it in memory. It's kind of complicated, but I'll break it down and make it where it's a lot easier to understand than right now. Right now, it's going to be kind of like, things are fuzzy. But we'll step through this. Just hang in there. We'll step through this, and I'll make it make sense. Okay, but first off, let's create an array. Let's talk about what that is. All right, an array is, think of it like a think about like a variable as being like a jar, right? It's a container. It can hold a value inside that jar, if you will. An array would be like a basket full of jars. So essentially what it can do is hold lots of different variables in it, but they're all going to be the same type. So for instance, if I say int open close brackets here like this in my array is going to contain a whole bunch of int variables, but they have to be integer because we said int right here. So this is a way of saying we want a whole collection of variables that are all going to be integers, and that's what an array is. That is literally what it is. They're very efficient, they're very fast, but the thing about array is once you create them, you cannot add or take away array elements. There's a way you have to use array list to do that, and I'll get into that in another video, but for now we're going to worry about just arrays. But these are extremely efficient in memory, and they do execute very quickly. I'll get into more detail a little bit here why that is, but for right now I'm going to keep it simple. I'm not going to dive into in depth on that one. Okay, so my array is going to be equal to a new int, and then we have to say how many integer variables. Remember, integer is about 32 bits, so it's like several different bytes there. It's like what, 4 bytes, I think it is, for an integer variable. And so each one of these, right, is, say we pass in number 5, which we were passing earlier. So we pass in the argument 5 into our function, right? So then that 5 gets assigned to num elements. So now num elements is 5. And then we're saying we want 5 elements or 5 variables, integer variables. And we want to store them into my array. We have to let it know how many we need because it has to create that amount of RAM. So if it's 4 bytes per integer variable, then it's going to be 4 times 5, which would be 20. So it needs 20 bytes for the computer to create this. So it creates this amount of RAM up on the heap and assigns it to a memory address to my array. And then my array now has a block of memory to hold exactly 5 integer variables. Now, it's important to note that the computer starts counting at 0. So your first array element is going to be 0, your second array element is going to be 1, your third array element is going to be 2, your fourth array element is going to be 3, and your fifth array element is going to be 4. So we're used to counting at 1. You're used to saying like 1, 2, 3, 4, 5, right? That's how you think when you count. But the computer doesn't start counting at 1, it starts counting at 0 instead. And you might be going, well, why would it do that? Well, because it works out that way with bits mathematically. With the computer, the way it stores numbers and everything. So because of that, it starts counting at 0. So it's a mathematical thing. Basically, we'd have to lose one value of precision. That's wasteful. So we're not going to be wasteful, and we're just going to have to learn how to think like a computer thinks. So we have to start counting at 0 instead of counting at 1. It's a little weird for a while when you're first doing this, but after you do it for a long time, you'll do it instinctively, and you won't have to think about it. But at first, you're going to have to think about counting from 0 instead of counting from 1 because it's so alien to you because we're just so ingrained to start counting at 1 instead of 0 because it kind of makes sense to do so. All right, so that's kind of the deal. So our first array element will be 0. That is why when we create our for loop down here, I am setting my count variable. Count variable is nothing but an integer variable. That's all it is. And I'm assigning it to start at 0 because I have to access that first element in the array. This for loop is what we call a counting loop. It's a lot like the while loop like we saw earlier. Only this loop, we know what the begin and end of what we're looking for is. And it counts up in increments, counting up 1 by 1 by 1 for each loop iteration. And it counts from a starting position to an ending position for your and counts all the way up to that. So when we're starting the loop, we say int count equals 0, semicolon, and this lets us start our for loop. And it starts us counting at 0. And then we're saying count has to be less than the number of elements. Well, this actually makes sense because num elements is 5. You might go, whoa, 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 whoa. We want to go up to 5, right? No, we really don't. We want to go one less than 5. And so if we say count is less than num elements, that works. You might be going, no, 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 there's 5 elements in the array, right? It's got to count up to 5. No, because we start counting at 0. You have to count for that. You have to count for the fact you're starting to count at 0. So if I count this up, right? If I were to count up to 5, and let's say this was greater than or equal to, which would be wrong, but if I were to count that up, I get 0, 1, 2, 3, 4, 5. That is now 6, right? So that is 6 elements. Uh-oh, we don't have 6 elements. We have 5 elements, right? Because 0 would be 1. 1 would be 2. That'd be 2 elements now, right? And then we get to the third element, which should be element number 2, right? So we have 3 elements. And then our fourth element would be number, basically, number 3. And then our fifth element would be number 4. And our sixth element would be number 5. We don't have 6 elements. Oh, so that has to be count is less than num elements. So that only goes to 4. Otherwise, we'll try to access an element we don't have. And since the operating system is what's in charge of assigning RAM to our program from memory, the moment we go to access something that we have not been assigned, we have an illegal memory operation, or basically we are trying to access an element outside the range of array elements assigned to this array, and the whole program crashes. So in order to avoid the whole program crashing, we need to make sure we go to the right amount. Now we don't want to go one less or one more because then we don't access all the elements in our array. So if we want to access all the elements in an array, we have to tell the computer precisely the right number of elements and the right number and the right range. Otherwise, it won't work. So that's precisely what we're doing here. I know that I'm always going to get it right every time because whatever gets passed into this function is going to be exactly how many elements are created, which will be exactly how far I need to go every time. So this loop will instinctively always go from the right starting point to the right ending point because I said it's going to be one less than the number of elements in my array, and I do one less because we start counting at 0 instead of 1. So it always gives us one extra one because of that. So we put a semicolon at the end of these because each one of these are lines of code. And then we're going to say count plus plus. Now, what count plus plus is, this is a post incrementer. And let's break this down. Basically, there's a lot of complicated stuff in this little video here. So basically, what this does, it says count is equal to count plus 1, like that. And that's what count plus plus does. It's very short. It's shorter than, say, this would be the same thing as saying count plus equals 1. Only they shortened it even further and said, you know what, we're too lazy to type that even. Let's just make it count plus plus. And they do. But there's some special magical features about count plus plus that you don't have in these over here. So these work in a very standard way. However, count plus plus and its brother, plus plus count, work a little differently. You might go, whoa, what's that? Whoa, wait a minute. We got pluses before and after. Yes, this is what's called a pre-incrementer, and this is a post-incrementer. And why does this matter? Well, it matters because it can make a really big difference on things. For instance, I can come in here and say I did this count as part of something. Let's say count was equal to 0, for instance. All right, cool. And we're doing something like that, right? Cool. And then I came in here and I said, and yeah, let's say we have an integer, it's integer, and let's create another one, and let's say int for total is equal to Oh, I don't know. Let's say it starts out at 0, 2. All right, cool. All right, so say we have a total here, and we're saying it is equal to 16 times count plus plus. Now, you might be thinking, oh, okay, well, yeah, exactly. What do you think the result of this would be? Well, what happens on this, since this is post, count is going to grab the value of count first, do all its mathematical operations, and after this entire line of code is done executing, then it's going to come back and increment count. So it's not going to do it ahead of time. So because of that, count is 0 up here, right? So 0 for count, and 0 times 16 is 0. So then total will be 0, right? Then after that's all done, then count will be 1. So then count will be turned into 1. So that's very different than, say, if we were to switch our plus plus on the other side of this. And this is pre-incremented instead of post-incremented. This is why it's called post-increment, because it happens after everything else is done. Pre-increment is like you think. It's going to happen before everything else happens. So what I could do is I can come in here and I can say plus plus count. This means that this operation is going to happen before anything else on this line of code is going to happen. So count's going to go from 0 to 1, right? And then 1 times 16 is 16, and then total will be 16. So the difference of 16 here for count for total versus if I put the plus plus on one side versus putting it on the other side. That's 0 for total, whereas the total will be 16 if I put it on that side. No joke. So this can really mess with you. If you don't work this out properly and everything, it can really mess with you, because what can end up happening is that you can end up having miscalculations. You can end up, on certain circumstances and different things, you can end up counting too far along on, say, for instance, your array access. If you were to put this increment directly in an array, and it wasn't a for loop, it would be something else, maybe like a while loop. Depending on how you went about it, or whatever, for finding the particular element, if you do plus plus versus before or after, it could mean the difference between accessing the right element or not accessing the right element, or going one beyond and crashing the whole program, or you get the idea. So in other circumstances, it'll give you a total miscalculation if you get it wrong, because you didn't think out the logic correctly, because it didn't get incremented when you thought it did, because you weren't thinking about it. So it's really important to understand the difference between post and pre. But not only can you do plus plus, you can also do minus minus. So what this would be a pre subtraction, and it works just like the plus plus does. So count here would then become -1. Because this have to get done before the rest of it. It'd be -1 times 16, and then total would be -16. Where this is different than if we were to say, again, count minus minus. Then we'd have 0 for our count, right? And then count would be times 16. So 0 times 16 is 0, and then total would be 0 here, which is, and then count afterwards would be decremented, sorry, not incremented, but it's called decrementing, to -1. And so then count would be -1 after the fact. So total would be 0 and count would be -1. So it's almost like doing two mathematical operations and assignments in one line of code, essentially, is what it's like. So that's what you're doing there, and that's kind of how that works. And maybe I'll do a demonstration of it sometime in another video to really make it hit home. But that's basically how incrementing and decrementing works with plus plus operators. Now, on this particular one, it's just a line on its own, so there's no order of precedence that matters here for its execution of this statement. So because of that, we don't have to worry about, hey, is it pre or post? I can make it pre or post. You can't do both. You can't do that, right? It has to be one or the other, right? But it doesn't matter if I do it that way or if I do it this way, because either way, it's still going to get incremented at the right time because it's its own line of code. So you don't have to worry about it. It's just not being evaluated with another statement. Another thing I can do, though, besides that, I could also say something like plus equals 5, and then this will go up by 5s, and it'll literally increment by 5s. So I don't have to increment by 1. I can increment by 2, by 3, by 4, by 5s, etc., etc. But in this case, I do want to increment by 1 because I am trying to count through each element in my array. So I need to say plus plus on that. Okay. We use our starting and closing curly braces on a for loop. And this starts the beginning of our code for a for loop, and this ends our code for a for loop. Alrighty. And if I come in here with this, I say my array, open bracket, count, close bracket. And this is how you access a particular variable in your array. So remember, your array is a container for lots of different integer variables, and I want to access a particular one. So since this is counting, it's going to start counting at 0 and then count up by 1 all the way up to the total number of elements in our array. Then we're, 1 minus the total elements array, which is, say, the end of our array. This is perfect for it. So it's going to access the first element in the first array on the first loop iteration. What I'm saying is, on the first time this for loop goes through its loop, count will be 0, right? That will let us access the array element 0 in memory. And then we're going to convert this to an integer. I'm taking this math library, I'm doing a dot random, which makes it a range of 0 to 1 in a floating point, and I'm multiplying that times 100, and then I'm saying typecast it as an integer, which will drop any decimal values that may be on the number, and then it'll assign that as an integer amount to my array. Essentially, this will create a range between 0 and 99. We got it going, well, why not 100? Well, because random will start at 0 and can go up to a decimal value of 1. It'll be 0 to 1. And then we multiply that times 100, your decimal value, I don't believe, will reach 100. It'll reach like 99.99999, but I don't think it will reach all the way up to 100. Possibly, but I don't believe so. So when we drop the decimal value, that will only get us between 0 and 99. So if I want to go up 1 beyond that, I would have to add 1 after this whole operation was done, and not with inside these parentheses, but outside the parentheses. Okay. And I'm just basically taking the entire result here, this whole result of this mathematical operation, and I'm multiplying it times int. I'm not multiplying it, I'm typecasting it as an integer. This makes this whole number temporarily an integer, which is what we need just for this assignment operation. We're assigning this into RAM for that first memory location. And I'll prove all this in a second, because it's probably really confusing right now. But I'm breaking it all down, and then we're going to go back through and step through the code, and it'll make a lot more sense then. But this is for pseudo-random. This is based off the time of the clock inside the computer, and it's not actually technically random. Actually, there's a case where the lottery used to be, if you remember right, used to be done with a computer to generate random numbers for the lottery. It was for pseudo-random. Let's just say it's not completely perfectly random. And an entrepreneuring programmer figured out that the lottery numbers were, he knew they were running off computers, so he reversed the algorithm and figured out what their timing was and everything for the numbers when they were getting generated, exactly when they were being generated and everything, and got to where he was generating the lottery numbers every week. And so he won the lottery a number of times in a row. And then they were wondering how he was doing, how he kept winning the lottery. And then he eventually had to tell them, it's like they made him tell him, he had reversed their algorithm and was figuring out the numbers to the lottery. So he made a lot of money. And so that's why you now see all the lottery is like using Powerballs where they fire them up into the air. Because it's totally random. And not for pseudo-random. And so that is why you won't see the lottery ever done on a computer again. But yeah, he figured that out. So for pseudo-random is not totally random. It is very much appears to be, but it's very close to totally random, but not quite. Just slightly not totally random. So yeah, It's not perfectly random. It's close to it. Okay. So anyways, let's return this array in memory. And this is going to get returned by reference. So it's going to return the memory address to this array and not all the different variables and the values in it. It's just going to return where this exists in RAM. So then when we come down here into our main, when we say int open close brackets to create another array, we call it my new array, which is a different array, equals create array, and we're saying open parentheses 5 close parentheses semicolon. We're passing in 5. We're telling it to create 5 elements. It goes through and does everything in that function we just went through. And then we're not saying new here. You might go, well, normally when we say new, we don't need to say new because we're passing back the memory address from a create array function. So it's going to get the same location in memory as my array. And they're going to share the same memory location for just a short moment in time. After the function is done running and this is assigned the memory location from my array is going to be destroyed along with the function up above. But the my new array will point to that memory location that my array used to hold, and it will now have all those values and everything passed to it. I'll prove it. I'll show you the exact memory addresses, and I'll show you that it's actually getting passed. I'll show you that in just a bit. Another way we could do this, and I kept it simple. You might think, no, you didn't. Actually, I did. It can get a lot more complicated than this. But for here, and we're just doing int count equals 0 semicolon. You might be going, well, why don't we just have the values from count up above, right? Will that affect it? No, because the count up above is part of the function up above, and it does not exist outside of this function. So this count is a totally different count variable than the one up in the function above inside the create array function. It's completely different. So this count only exists within inside this main function and not anywhere else. We're going to say count is less than my new array dot length. Well, now we don't have the number that's being passed in. We could create it and like set it there and then set it here, but I didn't want to. I want to show you another way to do it. This is a really cool way with your arrays. You can say my new array dot length, and this will actually use a method that will find the length of your array, and it'll come back as 5. And so no matter what the length is, it's a special function that goes in and finds the length of your array. It does it by using a for loop like we're doing and counting up all the elements in the array. That's essentially how it works. And then returns the number afterwards. So we don't have to worry about writing that or doing that. We just literally say my new array dot length, and then it finds the length of the array. And then we're going to say count plus plus to increment it. And in here, I'm just going to be displaying all the little values here for my new array, going through them one by one, looping through them, and appending them one to another at the end of the other one. And then afterwards, I'm going to say print new line to put a space between the build successful and this line here. You might be going, okay, none of that made sense. Right, so you probably need to visualize it. So let me just run this to show you how it works. And bam. 55, 29, 54, 22, 18. That's what we get for our result for this whole thing. All that code generated those numbers, but they're random. See, like if I run it again, 96, 65, 8, 92, 49. The important part of this, though, these are the different values that are sitting in our array. They got assigned to our different array elements, and then we're just displaying them back. So let me show you that by stepping through this so it will actually make sense. Because right now, me showing you that's probably doesn't explain squat to you. So let me hit debug, and let's have a look at this. All right. So my new array, length here, arguments, has nothing going on. Yay. And I'm going to step into my new create array function. Notice that num elements is now 5 because we passed 5 into it. So num elements is now 5 too in memory. Now we're going to be telling it, the array, that we need 5 elements in our array because num elements is 5. So if I say step over, I get exactly that. I get my array. It's that memory address 50, number 50, and its length is 5. And it is a type int array, open close brackets. If I expand this down, you can literally see all the elements. There's element 0 in our array. It's the first int variable. Then there's element 1, that's the second int variable, and you notice they're all 0. They're all equal to 0. Initialize it by default to 0 for Java does that. Some other languages like C won't do that for you, but Java automatically initializes it to 0. And then 2 here for our int, for our third int element, and then 3 for our fourth int element here, and our fifth int element is number 4. There it is, and it's 0 also. So let's try to have a look at this loop. We're going to end up creating our count variable here when we do this for loop. And it's going to have the requirement where it goes up to the num elements, and we're going to increment it one by one. So the first pass through loop, it's going to be 0. It's not going to get incremented on the very first pass because we're assigning it 0, and we're creating the variable. So step over, like that, and we now have a count, and it is 0. So we're saying grab the first element in our array, right? Because my array, element 0. Well, element 0 is this one right here. See that? So I'm going to say step over, and it's going to create that mathematical number there for randomness between 0 and 100. And it happened to randomly select 4, so that got assigned into the first element in our array. Now check it out. Count is still 0, but the moment we go and increment this, it's going to say count plus plus. And so count is going to be 1 plus 0. 1 plus 0 is 1, so count will be 1. And then it'll test the condition afterwards. Is 1 less than num elements? And num elements is 5, so I'll prove that num elements is 5. So is 1 less than 5? And the answer is yes, so it's going to do the next loop iteration. So step over, check it out. Count is now 1, and yes, it did go through it because it did meet those conditions. So now we're going to be accessing element 1 in our array, which is this one right here in my array. Alright, cool. And we're going to assign a random value between 0 and 100 to that one. So I'm going to say step over, and bam, it got 44 this time, and it's basically stored it into element 1 in our array. Now count is 1, but the moment we step over this again, count is going to be 2, right? And 2 is going to be less than 5 because count is 2 and num elements is 5 here. So it's going to be less than 5, so it's going to do the next loop iteration. All right. And check it out. Count is now 2. And we are going to assign our next random value into the element number 2 in our array, right? Because count is 2, so therefore we're saying access element 2 in our array. And we're just going to create a random number and put it in there. So step over, and bam, it got 28 stored in there into element 2. All right, so let's increment again. Say count plus plus. So count is going to get incremented from 2 to 3, and is 3 less than 5? Because 5 is num elements, right? If 3 is less than 5, then we can do the next loop iteration. It is, so it will. So now it's 3 here for our count, right? So now we're going to access our count, our element number 3, not a third element, it's our fourth element, but element number 3 in our array. And we're going to assign a random value into element number 3 in our array. So when I step over this, that's exactly what happens, and we got 3 for our element 3 in our array. That's actually quite funny, the fact that it's 3 for a 3. Anyways, it's hilarious. The probability of that happening is, well, 1 in 100. Oh gosh, that's hilarious. Anyways, let's have our evaluation here, and count is 3 right now, but if we increment it, it'd be 4. Is 4 less than num elements? Num elements is 5, remember that? So we're basically saying is 4 less than 5 when it gets incremented for count. And yes, 4 is less than 5, so it's going to increment it to 4, and it's going to do the next loop iteration. So I'm going to step over it, and you'll notice that count is now 4, and now we're going to be accessing the fourth element in our array because count is 4. So we're going to put the randomized number into my array and element number 4. Step over that, and I got it. And it happened to be 44 again. Yep, that's just the way it goes. Okay. Now, count is going to get incremented to 5. And then it's going to do a test of saying, is count of 5 less than num elements, which is 5. And the answer, of course, is 5 less than 5. No, it's not. So it's going to skip this loop out of this loop, break out of it, and get out of it. And we will no longer be looping through this, which is great because we've already filled up all array elements. So that's saying we can't have it just go up to num elements. We literally don't have another element. It went up to element number 4, and that's when it ends, right? So as I step over it, it skips out of this array, and it's going to return this array in memory. Now notice we're at memory location number 50 in our array. And every one of these elements actually has its own memory location too, believe it or not. So that lets us know it's an integer, and then that one lets us know the value. But yes, each one of these actually has its own memory location. But the whole thing has a memory location of number 50. So memory location number 50 is going to get returned. And I'll prove that. Step over. So now we get this whole thing happening. And nothing interesting. Okay, so be it. And let me step over it one more time so that way it returns that value. And so my new array exists now. And notice something. It is pointing to memory address 50, which was the same thing as my array. And check it out. It now has all the values in it that my array does. It didn't have to pass all these different values and copying of memory and all this stuff like you do when you do pass by value. Instead, it just pointed to where it was in memory and assigned that memory location to my new array. And so my new array didn't get allocated new RAM. Instead, it got pointed to a block of RAM that was identical to it. And so now it's now using that same memory location with that same number of elements. And so we can get away with this. We don't have to tell the computer how many elements we need in RAM because we're going to be passing a whole block of RAM with all the elements in it when we return it from our create array. So that's essentially what's happening underneath the hood with what's called a memory pointer. And it points to this and assigns that memory location to my new array. And so now my new array essentially is my array. They're essentially the same thing. Two names pointing to the same place in memory. Same exact thing. Literally, exact same thing. So when I come in here to my 4, my count is 0 because this is a new variable. It doesn't exist yet. Literally, check it out. Count is gone. It doesn't exist. It's because it all got destroyed when we were done running this create array function. So create array function is done running and it no longer exists. Everything's been destroyed that was in it, including my array. However, we passed the memory location to my array before it got destroyed to my new array. So it still persists in memory and we still have access to the values. All right. So count is going to get created. We're going to go up to the length of my new array, which will be 5, because that's how many elements are in my new array. And we're going to increment by count plus plus. All right, so let's have a look at this when we run through it. So I'm going to say step over it. And count is 0. So it's going to grab element 0 from my new array, which would be what? My new array. Count 0 is 4. So it's going to display 4 on the screen. And I'll prove that when I come over here to my output. I say step over. Bam, there's 4. It's kind of fun, huh? Alright, we're going to come here. Count's going to get incremented to what? Count is 0. It's going to get incremented by 1. So it's going to get incremented to 1. Because 1 plus 0 is 1. So step over. Bam, like that. And then now, when we tell it to display element 0, from because count's going to be accessing element 1 now, right? So accessing element 1, we're going to display the contents of element 1 to the screen with our print here. And we'll put a space between it from the previous one. So it has a space there, which is nice. We need that space. And so when I say this, again, boom, we got 44 got displayed on the screen. All right. So count is 1, so it's going to get incremented again. So count plus plus is going to increment it from 1 to 2. Step over it. All right, and then system here, print my new array. So we're going to be accessing element 2, 28. All right, so 28 is going to get displayed now. Boom. So now 28 got displayed. Let's have a look at our variable. Count is going to get incremented to 3 now. Boom. And then we're going to be accessing element number 3 in our array, which is 44. So on our output here, no, I'm sorry, not 44, it's 3. It's number 3, yeah, 3 is 3. That's right, that was funny about that. So that's right. Step over it. And so we get 3 here, so 44, 44, 28, 3. One last element in our array, right? So all that's left, number 4. So now when we loop again, it's going to increment it to 4. We have 4 elements in our array. We have 5 elements in our array, so we're still good to go. We're still less than 5 on my new array length. And so we need to access element number 4 in our array, and that's going to be 44. So 44 is going to get displayed on the screen. So I step over that, check it out on the output. Now it says 44. And we're done. So in our variables here, count is 4. And so when we increment it again, it'll be 5. And the length of our array is 5 elements. So is 5 less than 5? And the answer, of course, is no. No, it's not. And we're out of array elements, so we don't want it to loop anymore. So when I step over this, it's going to step out of the loop entirely. And it's going to create a whole new line. So that way the message here for running for build or whatever won't be on the same line with it. So I say step over it here, boom, it's like hitting the enter key, and it makes it go to the next line here for a print. Bam, and there it is, build successful. And we finished. And it worked. And that is how you do arrays with for loops in a program. And that's a breakdown of everything and how it works. Alright. You might need to take a break after this video. We covered a lot of complicated stuff and what was happening in memory with the computer and everything in detail. But we'll go into this stuff in more depth in the future as we go through it more and more. And we will cover array lists in the next video, which will cover how to dynamically create these array elements while our program is running, which is really useful. Think about like a grocery list, for instance. You need to be able to create the different items for the groceries that are to be purchased as they are purchasing the groceries, because you have no idea how many groceries someone's going to buy ahead of time. With this array here, you have to know ahead of time how many items someone's going to buy. And so that's not really useful. So yeah, we need to have it to where we can add elements to our array as they are checking out. So we're going to learn how to do that. But for certain circumstances, like this array here, it's extremely useful if you know ahead of time to use this, because it takes less memory and it runs faster. Oh, one thing I wanted to mention on this on the array. Notice how on these array elements when I was running through it, and you probably have a hard time finding this in any book or anything, but I'm just going to tell you how this works because I actually studied the compiler on this stuff. So let me just dive into this here real quick and then step over to my array here. Boom, boom. All right, so instead of coming here. All right, I want to point out something to you. Just going to step over these a few times, fill these values in. Okay, see my array here? The amazing part of this, and the reason why this is so daggone efficient, and I'll get into this further later on, is that when arrays are created in the programming language, they actually create the different locations here in memory, one after another in RAM. So what this means is when we go to array lists in the next video, they're not created one after another. They're created spread out through the RAM into whatever was convenient at the time for it to find a location for it. This actually creates a block of RAM. And so when the computer goes access these values, they're one after another in RAM. So it can find all the values extremely fast. When it goes to grab these from RAM, it goes for the first element, then the second element, the third element, the fourth element, the fifth element. They're all right next to each other in RAM. So when it goes to read them back, they're like pow, 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 super fast. So if you're trying to do something with a high computation, like really fast type program, needs a lot of speed, then array is awesome for that. It's really, really good. So that way you can pull your values back really fast. In the case of an array list, you can't do that. You can't have them lined up one after another like that exactly together, because ahead of time you don't know how many you need. And so you get chunks of them or pieces of them in different places in RAM wherever it can find a spot for it. And so when the computer has to read it back, it has to read in that value for that one element and then skip a bunch of stuff and find the next element, read it in, so on and so forth. So it takes longer for the computer to read back the values from an array list than it does from an array. Because the array is going to have all those different elements in memory back to back, one after another, pow, 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 pow. So it's really, really fast to access it this way. So that's something I want to point out because I do game programming, so I do a lot of performance type programming, and this will really help you with performance type programming, understanding how arrays lay out in memory and in RAM, and it really matters a lot. So anyways, there's that, and I hope you found that helpful. Anyways, my name is Nate Nessler. This is for Hyperactive Studios, and I hope you found this informative. Thank you very much.